Okay, so today I'm going to be talking about bootstrapping. The first part is for univariate data, and bootstrapping is a resampling technique which allows us to generate additional synthetic data sets. We can then calculate our statistics for each sample to generate a distribution of the statistics over the sample. And we use this technique in estimating errors. We can investigate how each variable in the set impacts the other one, and it doesn't tell us how they interact, however. We can also predict variables. They need to be independent and not connected, and bootstrapping is used to see how good our regression model actually is. As you can see, we only have univariate data. So for the bootstrap sample, we're going to use this and randomly select the sample. And in the bootstrap statistics, we're going to use this sample, use the statsfn function and the number of samples. So for example, if we want 20, we'd say 20 here. So now this is going to generate the samples from our data and in the range of the number we are going to provide, for example 20. So to get the standard deviation for part 1, we pass it in here. So we call the bootstrap statistic function, we pass in our sample data for x. For the statsfn, we're passing in standard deviation because that's what we want here, but later we want stochastic, so we're going to pass it in here. And then the third thing is the num samples, so which we chose to be 20. Then I just printed the standard deviation, which is for 20 synthetic data sets, and then the mean of the standard deviations. So here I have my output, and this is the standard deviation of each variable in the data set, and then this is the mean of the standard deviations, and it's 2.9. The next part is for multivariate data, so using bootstrapping for multivariate data. This is to generate synthetic data for this set we have here. We have to create a multi-regression model, so we can run regression model lots of different times on different data sets, and we want to pass in our bivariate data, and we want to correspond the values. So for example, 1 and 1 should be linked up with 1, and 0 and 0 should be with 0. So I'm using all my code for my previous task for the multi-regression model and the gradient descent stochastic. And then, so in a bootstrap statistic, we're passing in the x data, we're passing in the y data, we're passing in the statsfn, which is going to be the gradient descent, the stochastic gradient descent, and we're passing in the num samples. First thing we declare is stats, and we're showing that it's a list by putting equal to square brackets. And then we're doing for I in the range of the num samples, so you do a loop for I in the range of the num samples. So if the num samples are 20, it's gonna loop through this 20 times. And then inside we're calling the bootstrap sample, we're giving it our data and sample, and we're getting back the samples to apply functions, and we put all of this into a list, and the output will be a list. And as our bootstrap sample takes in data, so this is why we have to zip the x and y, it only takes in univariate. Okay, so with the x sample and the y sample, so when the sample data comes out, we need to separate it from 0, 0 and 1, 1. So we want to put the x and y values to get the x and y values. So first thing we have to do is split the data. So we can split our data by using zip star sample data, and so this will unzip it for us. So by doing this, it's going to split. So our first elements are going to go into the first object, and then our second elements are going to go inside our second object. And it will be the same list, but it will be unzipped. so now you can separate it into x samples and into y samples. Okay, so after this we're going to declare as x, which is the list of the x samples which we just unzipped, and then we're going to declare y, which is a list of the y samples that we just unzipped as well. And then our stat is going to be our stats function, and we're going to pass in our x and our y. And then the last thing we're going to do is we're going to append, so the stats that we declared up here, we're going to append or add it into that list, our stat, and we're going to return the stats. Okay, so the last thing we have to do is print out our function for the gradient descent. So we're calling our bootstrap statistic function here. We're passing in our x and our y, which are up here. So our x and the y. And then we're going to pass in our gradient descent stochastic function, which is up here. And we're going to pass in the number of samples we want. So in our case we want 20. And like previously, we wanted to get the standard deviation, so this part is where we called, so example here, and to get the gradient descent one, we just passed it in here. Okay, now to see our results. So this is the output for the multivariate data. So what's returned to us is a list for the multi-regression model. So as you can see that all the values here, like for example the 30s or the 0.9s, the minus 1.6s or the 0.5s, they're not the same, but they're very close, like, to each other.